We're going to master a skill you already use every single day, probably without even realizing it. We're talking about the art of taking messy, complicated numbers and turning them into clear, powerful tools. Welcome to the world of approximation.
Okay, picture this. You're at a huge Super Eagles match, right? The stadium is absolutely packed. Now, if someone asks you to get an exact head count, well, that's almost impossible. You're not going to count every single person one by one. So let's say the official attendance was announced as 51,387. Would you really remember that exact number 5 minutes from now? Nah, probably not. In a normal conversation, that level of detail is just noise.
So instead, your brain does something really brilliant. Totally on its own, it starts searching for a number that's, close enough to be accurate, but simple enough to actually be useful.
You just say, wow, there are about 50,000 people here. And boom, right there, that's approximation. You've just made a tricky number simple and useful. Now let's break down how we can do this on purpose.
All right, so let's dive into the art of approximation, which is really all about learning how to get a number close enough for whatever you need it for.
You see, at its core, this is all about one thing: simplification. We're just stripping away all the messy details to find the number that actually matters. Okay, so our first tool in the toolbox is all about getting precise with things like money and measurements. We're talking about decimal places.
And the best part? You already get this, I promise. Just think about our currency, right? The whole numbers are the naira. And those little digits that come after the point, well, that's the kobo. That's all decimal places are. It's that simple.
And the cool thing is, there's just one simple rule for all of this. Seriously. First, you find your target digit. Then, you look at its next-door neighbor to the right. If that neighbor is 5 or bigger, you round your target up. If it's 4 or smaller, you just leave it alone. That's the whole game.
All right, let's put this rule to the test. Imagine a fuel cost is calculated down to this super precise number. The thing is, the fuel station only deals in naira and kobo. So, our job is to round this down to 2 decimal places.
Okay, so step 1, find our target. The problem says 2 decimal places, so we're looking at that second digit right after the point, and that's the 3.
Step 2, we peek at its next-door neighbor, the decider digit. In this case, it's a 6. So what does our rule say? Is it 5 or more? Oh yeah.
And that means we've got to bump our target digit, the 3, up to a 4. And there you have it, our final answer, 845 naira and 74 kobo. It's simple, practical, and it's exactly what we need.
Okay, let's switch gears. Now for our second tool, which tackles the complete opposite problem, those huge, massive numbers. For this, we use something called significant figures. Basically, significant figures are just about spotting the most important digits in a number. The rules are pretty easy. Any number that isn't 0 is always significant. Zeros can be a little tricky, but if a 0 is sandwiched between other numbers, it counts. Zeros at the very beginning, though, nope, they don't count.
Let's take a real-world example, something like a census report showing a population of over 12 million. A politician giving a speech doesn't need every last digit, they just want the key information. So our job is to round this number to 3 significant figures.
So we just count from the left from the very first non-zero digit. The first significant figure is 1, the second is 2, and our target, the third one, is the 4.
And now we use that exact same rounding rule we just learned. We look at the very next digit to the right of our target, and our decider here is a 7. And since 7 is definitely 5 or more,
We round our target, that 4, up to a 5. Then all the other numbers just become zeros to hold the place value. So we end up with a nice, clean 12,500,000. See? Much clearer, right?
Okay, so we've got the tools down. Now let's have some fun and apply them to a few logic puzzles.
all right, check out this table. You've got an input, a rule, and an output. You see the pattern? 7.82 becomes 8. 15.3 becomes 20. The rule here is always rounding to one significant figure. So with that in mind, what do you think the output should be for 4.41?
Go on, take a second. Apply that rule. The input is 4.41. The rule is round to one significant figure. What's the answer?
Did you get it? The answer is 4, because, well, the first significant figure is 4. The decider right next to it is also a 4,
and that's less than 5, so we leave our target alone. The answer is 4. See? You just cracked the logic puzzle using approximation.
So, what did we just do here? This is more than just a math lesson, you know. This is like unlocking a new superpower for making sense of a world that is just full of numbers.
Think about it. Your mental toolkit is now fully loaded. You know how to get super precise with decimal places, how to bring some clarity to those massive numbers with significant figures, and you even know how to use both of those skills to crack logic puzzles.
Because at the end of the day, that's the real goal, isn't it? It's not about just memorizing some rules. It's about mastering the ability to take any number and shape it to whatever level of accuracy you need for the job at hand.
So, here's my challenge to you. As you go about your day, just keep your eyes peeled. From the news you hear to the prices you see, numbers are being simplified all around you. The question is, now that you know the secret, where are you going to spot approximation at work?